Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about quadratics in our Algebra 2 course. So this is a homework assignment sent in by a student. I think there's 4 or 5 questions that we're going to tackle, so let's get started. In order to solve something by factoring it, we ideally, if we're not given a type of factoring that we should complete, ideally we're going in by using the most efficient form of factoring possible. And whenever we have a solo x squared with no additional x's, or x squared or x cubed or x anything else, it's just x squared. My recommendation is to go straight in and solve by the square roots method. So our goal is to get this x squared all on its own. And then once it's by itself, then we could go ahead and square root both sides. So I'm going to go ahead and add 1. So I get 9x squared equals 1. Divide by 9 on both sides. X squared equals 1 over 9. And then at this point, because my x squared is on its own, I can absolutely go ahead and square root both sides. Now when square root both sides. Now when I square root the right-hand side, I know that when I have a radical, I can put the radical kind of separate for the top and separate for the bottom. So essentially I go in with root 1 over root 9. I also know I can't have a radical in the denominator, but lucky for us, both 1 and 9 are perfect squares, so we're in a good place. And we could say that our x is going to equal positive or negative 1, since 1 is the square root of 1, and 3, 1/3, because 3 is the square root of 9. The other way to do this is by going in for the difference of 2 squares. It's not my favorite method, but you'll get the same answer. You could say that 9x squared can become 3x and 3x, and this 1 could become both positive and negative 1. And then you essentially set each of these parentheses equal to 0. And so you end up with x equals negative 1/3 and x equals positive 1/3. You see, you end up with the same answer. I think this is a little bit more efficient where you're not doing as much mental load. I think, anyway, both are totally acceptable. Okay, the next question that was given is kind of like a multi-part step, multi-step question. Whoa, that was a mouthful. So the original parent function of this function is just the x squared function. It's the cubic function. The transformations are that we're gonna move 7 to the right, and then we're going to vertical stretch by a factor. Well, I guess by a factor of 2. I'm not going to write that in. Vertical stretch by a factor of 2. And then sketch the graph. So sketch the graph, ideally what we're doing is we're going in and we're moving 7. So we're going to hit 7 here. This is going to be my 0. And normally quadratic functions, whenever I draw a quadratic function, I'll have the very bottommost point, which is my vertex. And then from my vertex, I'm going to go up 1 over 1. And then from that second point, I'm going to go up 3 over 1. And so this up 1 and up 3 is going to end up changing because we have a vertical stretch by a factor of 2. So instead we'll go up 2 over 1 in either direction, and then up 6 over 1 in either direction. So our graph, that's a weird looking, whatever, you get the idea. It should be more like a U-shaped graph versus a V-shape like this one is kind of looking like, but whatever, nobody's like, my graphs are never perfect, so it's fine. But you're ideally going and stretching this, so this section here becomes 2 over 1, and this section here becomes 6 over 1, because you're just doubling. So if this was a vertical stretch of 3, we would go up 3 over 1, up 9 over 1. If this was a vertical stretch of 1/2, it's a vertical shrink, I should say, of 1/2, we would go 1/2, up 1/2 over 1, up 1.5 over 1. So whatever this number is right here, we're essentially taking this number and multiplying it by the 1, the 3, the 5, the 7, the whatever, as we continue to do the graph. I'm not quite sure. Oh, that should say right with an E, not right without an E. Right G in terms of F. And they did say something about F is somewhere else in the book. So I'm not quite sure what they're looking for, but my anticipation is they're saying that like f of x is x squared. And what they want is for you to say that g of x is double f of, hold on, is double f of x minus 7, so, something along these lines. If I'm not mistaken, that's kind of what they're looking for, but I also don't know what they mean from the instructions because I don't have the other page. So I'm gonna say like I'm not 100% sure on that, but that's kind of what I think we're going with when they ask that question. Okay, so the other thing that we have is another multi-part question. We are given a function. We want the standard form sketching the graph, the vertex, the axis of symmetry, and things like that. So when I go in and when I see this and I know that I need it in standard form, this is already in standard form, so I'm not quite sure what they're looking for. Maybe they were looking for vertex form. And in order to find vertex form, there are two ways to do it. You can either complete the square, where you would kind of take this, this B portion and you would go B over 2 squared. And I wonder if maybe I didn't realize what they were looking for. Maybe they were looking for vertex form, but I do know that this is standard form. So we're just going to go in and solve it with vertex form because it's something that you're going to need to know anyway in Algebra 2. So we might as well. So in order to find the vertex form, we're first going to look for the axis of symmetry. So it's part of the things that I need to solve. So my axis of symmetry is going to be -8 over 2 squared. So -8 over 2 is -4, and that squared is 16. So I know I'm going to add 16 and then subtract 16. So I'm going to have, well, that doesn't quite make sense because it's already a perfect square. So let's just call this no. We are going to right away rewrite this as x minus 4 squared, because when I factor this out, I know that 4 times 4 is 16, and I know that 4 plus 4 is 8. And if both the 4s are negative, they'll give us -8 because -4 plus -4 is -8. So this is my vertex form in the sense that I'm not moving up or down in my function when I am graphing it. So then the other thing that we need to remember is when we look at vertex form. So for example, if this is vertex form, I've got my stretch, and then I've got the H and the K, and that really gives me my vertex. And so in this case, because there's like this +0, and because there's this 1 in the front, I don't have any vertical stretches, but I do have a movement of 4 units to the right and 0 units up or down. So I know my vertex is going to be 4, 0, and my x-intercept is also going to be 4, 0. So when I do sketch this graph, I'm going to hit 4, 0. And because I don't have any stretches or shrinks, I know I'm going to go up 1 over 1, just like I did with the other one. In here, I'm going to go up 1 over 1, up 3 over 1, up 5 over 1. However big your graph should be, that's kind of where we're looking for that particular piece. If you see already that this is, I kind of wanted to, okay, let's backtrack for a second. If you already see that number 3, when you look at that problem, is already a perfect square trinomial, meaning the first term is a perfect square, the last term is a perfect square, and the middle term is a combination of each of those perfect squares, then you don't have to complete the square because it's already completed. It's already got perfect squares on either side, right? On either end of the function. Then you can go straight into factoring it and calling it kind of what it is. I was hoping that I would show you completing the square problem in this case, but I definitely have a completing the square problem in another video that I'm sure I can link in the description. So yeah, I think that's it. I think we've put it into vertex form, but this is already standard form. We've graphed the function. Oh, our axis of symmetry is x equals 4 because we know that our line of symmetry, right, our axis of symmetry is wherever my vertex is on the x line. And since my vertex is on the x-axis, I know that I don't have to have any other x-intercepts because the vertex just hits the graph one time. Okay, so let's take a look at this next one. Is the next two are actually word problems. So it says find two positive real numbers whose product is a maximum when the sum is 110. So we know we're looking for two numbers. We could say we could have like x times y, right? And we know that their product, we're looking for the maximum. So when we're looking for the maximum, we're looking for that vertex, right? And realistically, we're looking for the y value, right? Because that's normally where we look for the maximum or the minimum is usually the y value. The other thing that we have in here is that their sum is 110. So I could say like if one of them is x, the other one is going to be 110 minus x. And when I do that, I know that like, let's say x is 5, right? 110 minus 5 is 105. And so those two numbers kind of make sense, whereas one is 5, the other is 105. Their sum is 110. But we need to now find their product to see which one is going to give me the maximum amount. Because there's a lot of numbers that could add up to 110. In this case, they also tell us that our numbers are positive. They also tell us that our numbers are real. So we have some parameters that if we end up with a funky answer, we know we might have to reject something and go from there. So I'm going to start with this and I'm going to go ahead and I'm going to distribute and I'm going to say, okay, x negative x squared plus 110x. And the reason why I chose negative 110x first, I guess I could have done it as 110x minus x squared. Both are totally acceptable, right? And so now in this case, I'm going to go ahead and set it equal to 0. What I can do also is divide everything by -1 in order to get me to have a positive x squared. And that should work a little bit better. So now we're going to go ahead and we're going to solve for that axis of symmetry, that vertex, right? So I said in the earlier example, b over 2 squared is going to give me that axis of symmetry. So I'm going to end up with negative 110 over 2 squared. Yikes, that's going to be, it looks like that's going to be incorrect. Yeah. Let me think. My bad. Hold on. It's not B. It is not all that. It is negative B over 2A that helps us find the vertex. So then in this case, I would end up with 110 over 2, which is 55. So now 55 would be my number where if I multiply 55 times 55, I end up with 3,025. And if I add 55 plus 55, I end up with 110. So let's say I did 54 times 56, just to give, an example that where it wouldn't work with a different number. 54 times 56 is 3,024. If I did 53 times 57 would be 3,021. So we're looking at 55 times 55 would be the maximum point. So both of my numbers are 55 and 55. Okay, so normally when we look at word problems, we're either looking for a minimum point, a maximum point, and in most cases, we're going to find that minimum or maximum point with a vertex, right? Because that's kind of where my vertex is, right? So when I graph either a happy face or a sad face, I'm either right here at this bottommost point or right here at this topmost point. And that's going to be either my minimum cost or my maximum cost. In this case, we're producing whatever light fixtures. Honestly, it doesn't matter what we're producing. Almost every single one of these problems, you have some sort of something that's happening and you want the minimum cost, the maximum cost, the minimum amount of something, the maximum amount of something. It's honestly, it's just a slew of the same type of question worded slightly differently. So your goal is really to look and find the equation and look to see, are you looking for the minimum or the maximum cost? The other option is what would happen if you would have a cost of 0. So when you have a cost of 0, you would just replace the C with a 0 and solve for X. But in this case, we're looking for a minimum cost. So we're looking for this piece down here. Now, this is my vertex. So we're going to go ahead and we're going to find that vertex. So we're going to start off by the axis of symmetry first. And I'm going to rewrite this entire function so that it looks kind of a little bit better in my opinion. 1/4 x squared is the same thing as 0.25 x squared. Minus 10x plus 800. And we know that we're doing negative b over 2a for the vertex. So my b is negative 10. So negative 10 is just regular 10. And we're dividing. We've got 2 times a quarter. So we've got 1/2. We know that anytime we do division with fractions, we keep change flip. So we're going to have 20. And 20 is going to be the X value. 20 is going to be the amount of units that we've produced, right? And so in order to find not the minimum, in order to find not the amount of units that we want to produce, right? We want to know the minimum cost. Actually, it does say how many fixtures should be produced. So 20 fixtures should be produced. So we should produce 20 fixtures. And if they ask what the minimum cost would be, we would go in and we would take this 20 fixtures and plop it into each of these X's so that we would get this total cost of C. Anyway, I hope that this was helpful and not super duper confusing. I will see you in another video when I try to explain something else. All right, I'll talk to you later. Bye.